At the University of Arkansas, there is a project called Everything is Alive. Pervasive computing is megatrend. Computing has migrated from the mainframe to desktop, laptop to cell phones, and embedded computing is increasingly integrated into the object like cars, similar to the way we develop a semantic web by adding metadata to web objects. We can see coming Internet of Things, where every individual physical object has unique identity provided by technologies like RFID. We talk about smart world full of smart objects. The objective of this project is to gain an understanding of and learn how to design smart objects. Our long-term aim is to help to create a collection of interoperability standards that provide a migration path to convert a world of ordinary objects into a semantic world of smart objects. We believe that there are two potential advantages of using 3D virtual worlds to understand the future smart semantic world. First, modeling is low cost when compared to developing real-world technologies. And second, modular services that we develop for interoperating with virtual world may transfer more or less directly to the real world. We believe that what makes a smart object smart is the protocols it obeys. To convert the ordinary object into a smart object, we have to think about several problems like explicit identities, APIs, and not only the communication between the object and humans, but also the communication between the object and object. People tend to think to make an object smart, the object itself has to be smart, but we think differently. This bookshelf showed an example. Book itself is not seen as a smart object. However, in the real world, any book is assigned a unique number called ISBN. We can use this number associated with each book to retrieve more information. This setting assumes that each book is labeled with some identifier like RFID, which stores ISBN number. Therefore, if you scan any book with mobile RFID scanner, which is wirelessly connected to the internet, you can get a lot of relevant information from the internet. This mobile scanner gets information from API of Amazon.com, so you can see the basic book information like author and prices. Also, you can see the review of the books too. This protocol turns the books into something more than a book. Also, if you touch an antenna of this bookshelf, it scans all the books on this shelf and keeps updating the database. So, if you ask a shelf to locate certain books you want to read, or you can use a database to suggest what kind of the books you may want to read next. Like in such, I'm sure that we can make any ordinary object into a smart object only with the simple protocols. Now then, we thought that if we could generalize this idea and apply it to other things. In the world with a lot of pervasive computing, many people are overwhelmed with new technologies. Suppose you spend a year to learn how to use a complex device, but the next year, new device may be completely different from what you know of. What people really want is smart device, but less complex. This is the communication aspect of a smart object. As you can see, there are several objects in this room, like AC, bed, fan, X-ray machines, and so on. If you want to control any object, first things you have to do is to learn how you can use them. The way you change the angle of the bed and the way you turn on or off the AC is completely different. However, what if you can control all objects by one controller? This is what we call universal remote. You can see that each object is attached with antenna. Similar to the way the books with ISBN works, we assume each type or model of the object assigned with a unique identifier. The blue ball floating in the air can show you the simple demo. If you click a blue ball, it scans object with antenna around, and it will get the set of the IDs and of all nearby objects. assumes there is a cloud server which keeps API information of any product with a certain ID. The ball connects to the internet and retrieves APIs for each object by using ID. Separating the interface of the device from the implementation benefits both end users and developers for the same reason that the pull-down menu benefited them in the 1980s, giving a common look and feel to a wide variety of applications. Developers benefit because separating the interface from the device can reduce cost of designing physical interfaces. And the end user benefits because it becomes easier to control a device the person has never seen before, because the interface style can be familiar. This kind of the cloud technology made it possible to store the intelligence in somewhere in the internet. We can store more object-specific information like where the certain object is bought, or who is the owner, or more things. All the objects are seen as networked together, becoming smarter. We humans are pretty self-centered. We think being smart distinguishes us from the reactive objects like thermostat and pet, and passive objects like chairs. But this is about to change as we associate knowledge, action, and rules with the object in the world around us. We can learn how to do this using 3D virtual worlds, but this also helps us to understand how to translate these capabilities to the real world, so putting RFID tags or barcode on the object. We can use smartphones to identify and associate information with object, and that information can include means to control the object as well as security APIs to ensure only the authorized personnel can fire a gun or turn on the thermostat.